Problem. So in this video, we're gonna be solving this problem. So here is the problem statement. So here we'll begin an array of zeros, ones, twos, threes, and all the way to an integer called n's. So basically, the array can contain multiple value of zeros, multiple value of ones, and multiple value of twos, and all the way to multiple value of n's. So which will be placed in the given array in random order. So the output of our algorithm should sort this given array. So for example, if you say see this one over here, for in the first example we have an array whose value will be zeros and ones, and also to the input of our algorithm there will be an integer called n, which tells us the highest value a number can take in the given input array. So when n is 1, it means that the highest value in our given array is 1. It means that our array can contain values of zeros or ones, and the output of our algorithm should be like, first we have to have a group of zeros and we have to have a group of ones. And suppose if we see the second example here, this n is equals to 4. It means that the highest number in our input array is 4. It means that the input array can contain group of zeros, group of ones, a group of twos, group of threes, and group of fours. And output should look like this. First we should have group of zeros, followed by group of ones, then followed by twos, threes, and fours. Yeah, so this is what the problem statement is all about. Now we'll see three approaches to solve this problem. So the first approach is simply can be solved using an sorting algorithm, a standard sorting algorithm like insertion sort or a merge sort or anything else. Or else we can use a sort library function as well. It means that suppose if we take Java programming language as an example, in arrays class there is a function called sort. So when if we use this sort method of an arrays class upon a array, which will essentially sort the given array in ascending order. So basically, in either case, even if you use a sorting algorithm or a sort library function, which will essentially sort the given array, the best time complexity which we'll get in terms of big O notation is n log m, because even the most efficient algorithm will take an time of n log m in big O notation. Yeah. So so this is the first approach which we have saw. So basically we'll check out the next approach, which in which we will be decreasing the time complexity of the algorithm. So the second approach is like, first we'll just be traversing the entire array, and then we'll be storing the count of zeros, ones, twos, and n's in a map, or else we can say as variables. C0, which represents number of zeros, C1 represents number of ones, and Cn represents number of n's in the given array. And after we got the number of zeros, ones, and twos, and n's, we'll be traversing the array again, and first we'll put C0 number of zeros in the array. Next we'll put C1 number of ones in the array, and next we'll put C2 number of twos in array, and all the way to the n's. So this is the idea of this algorithm. So even this approach will take a time complex of big of n. It is less when we compare it to the first approach. But this solution is not a recommended approach. The reason is because this solution is not a stable sorting algorithm. It is a unstable sorting algorithm. So what is stable sorting algorithm and unstable sorting algorithm? So I'm not going into in detail of what is stable and unstable sorting algorithm, but I'll just give a high level overview. So here consider an example where people are standing in a queue to a concert or something else. So each person standing over here is holding a something called a ticket. So each ticket will have a number called priority number. So the person with tickets with priority number 0 has eligibility to enter the concert first, followed by tickets with priority number 1. At the end, the tickets with priority number 2 will enter the event at the last. So now if we use an unstable sorting algorithm, so essentially since people are standing in a queue randomly, so now we have to sort the persons such that the person with tickets priority 0 will be first, followed by persons with priority with 1 tickets, then followed by persons with priority 2 tickets. Yeah. So to do this, if you use an unstable sorting algorithm, it will sort the on a high level it will sort the zeros, ones, and twos here. For first we'll have zeros followed by ones and follows twos. But essentially, if we check in a group of ones or a group of twos or a group of any numbers, will essentially there is a chance of losing the relative order. It means that this is if we check the group of ones, here the person with name higher is first, followed by person with name Kiran. So this is the result after the sorting algorithm. But if we check the group of ones before sorting algorithm is executed, the person with name Kiran is first, followed by person with name higher. After the sorting algorithm, the relative position between these two persons in a group of one has lost. So this is how an unstable algorithm will result in. So whereas if we use a stable sorting algorithm, the result will looks like this. Over here, if we check the group of ones, we have a person with name Kiran first, followed by person with name higher next, which is same even before the sorting algorithm is executed. In the group of ones, the relative position between the person has not been lost. So this is the difference between a stable sorting algorithm and unstable sorting algorithm. So essentially, since we are just in this approach, since we are just getting a count of all the numbers, and then we are just placing count zeros first and ones next, and all the way to ends based on counts. In a particular group of zeros, ones, or twos, we'll lose. There is a chance of losing the relative order between zeros or ones or twos. So since this is unstable algorithm, so this is also not a recommended approach for this problem. So now we'll see the final algorithm, which is a stable sorting algorithm. So basically, before going through this approach, basically our problem is to sort an array of zeros, ones, and twos all the way to n's. So similarly, before going through this problem, I'll highly suggest you to go through a problem where we have to sort zeros and ones, and another problem where we have to sort an array of zeros, ones, and twos. So if you go through those two problems, then understanding this problem will be very easy for you. So understanding this third approach will become very easy when you go through these two problems, sorting an array of zeros and ones and sorting an array of zeros, ones, and twos. So I'll leave the this sheet which I have been displaying here in the link in the description of this video. So this sheet will essentially have these two problems where so you can go through this, or else you can go through some of my previous videos as well where we have discussed these two problems: sorting array of zeros, ones, and twos, and sorting an array of zeros and ones. So if we go through the approach of these two problems, then this third approach of this problem will be easy to understand. Yeah, so now let us come back to here. So now we will see the third approach, which is an approach where we write this table sorting algorithm. Yeah, so the idea of this approach is to use something called markers. So I'll say this approach as I refer this approach as a concept of markers. Yeah. So what is a marker? So now since we have an array starting from zeros all the way to n's, so it means that we have n plus 1 distinct numbers. So for this n plus 1 distinct numbers will have a marker all the way from p0 to pn, where p0 is a marker for zeros, p1 is a marker for ones, p2 is a marker for twos, p3 is a marker for threes, and pn is a marker for n's. So each marker p1 to pn represents a group of same numbers. Yeah. So, but what does a marker value contains? So, a marker uh, represents index in an array, index in our given array, such that all the values. Suppose if we take a marker called pi, so the pi represents an index in the array, given array, where all the values, all the elements which are having value I are left to this position pi. So p0 represents the position in the array where all the zeros are left to or on the index p0. P1 represents the index in array where all the ones are left to or on the index p1. So this is what the markers represent. A marker P1 represents a group of values, elements with values I, and markers will have the value as the index in given array, such that a value I, all the values I, will be left to the index Pi. So this is what a marker represents and what markers contain. So uh, so so ideas of the idea of this algorithm is to is to use this marker concept. So to do this, first we'll be looping all the way from first element to last element of an array. So when we are doing it, when we find a value called I, we will just make sure that we'll just make to send this I to the left of index pi. So when we find value 0, we'll make sure to send this 0 to the left of index p0. When we find 1, we'll just make sure to send this 1 to left of index p1. So once we have when we finish going through all the elements in the given array, so this will essentially makes that all the values are at their relevant position. All the values, suppose I, are at their relevant marker pi. All the zeros are at relevant marker p1. So suppose if we see this example, the after sorting the array, all the zeros are left to this pointer po or the pointer or marker pos of 0. All the ones are left to this marker pos of 1. So pos of 1 represents group of ones, and pos of 2 represents 2, and pos of 3 represents 3. Yeah, so this is the first or outer layer of idea of this algorithm is to iterate through all the elements in our array, and then send the whenever we find a value I, we need to send this value I to the left, to left of the relevant position given by its marker pi. So when we find I, we'll be sending this Y value to the index left to Pi. So this is the idea of our outer layer of idea of our approach. So now, before going through the in-depth or next layer of our idea of our approach, we'll just see how to create a pointers. So now we have seen that PO represents zeros, P1 represents ones, P2 represents twos, and Pn minus 1 represents Pn minus ones, and Pn represents n's. And idea of our approach is to loop through all this and send the relevant and send the value to its relevant pointer index. So now, when we say that when we find 0, we'll be sending the 0 to left to relevant index p0. When we find n minus 1, we'll be sending n minus 1 to the left of relevant index pns1. So if when we find n, even if we don't send this n to any position, it won't matter. The n's will be at the end of the array. This is because we are making sure that all the values from 0 to n minus 1 are at their are left to the relevant pointers. This will essentially make sure that all the value elements with value n are at the end of the array. So due to this, we don't need a pointer called pn. We just need a pointer all the way from p0 to pn minus 1. Yeah. So how do we create a pointer? So we'll just create a pointers using an array. So we'll create an array. Let us say the naming as pos. Pos represents the positions with the size as n, and each element of this array represents a pointer, where POS of 0 represents a group of zeros, and the value of PO of 0 is the index in the given array, such that all the zeros are left to this index P of 0, and POS of n minus 1 represents n minus 1, and at the end all the n minus 1s will be left to POS of n minus 1 index, or at the POS of n minus 1 index. So this is how we create our pointers, and we only need n pointers, not n plus 1 pointers. Yeah. Now, since our first layer of our approach, which we have discussed, is to iterate through all the elements of the array, and then send the elements to left to the position of its relevant pointer, right? So in this approach, we have to loop through all the way from first to last element. We can reduce this traverse length by changing the starting position of some of our pointers. So since we have n pointers, we'll just take n by 2 pointers. Let us say n by 2 as k. We'll start the first k pointers from the first element, and we'll start the next k elements from the last element. Okay. So what does this do? So when we start every pointer from the first element, and when we start iterating from first element to last element, and send the value to its to left to the relevant pointer, we are just sorting our array from left to right. Now, when we start half of our pointers from left side, when we start and half of our pointers from left side, we are making sure that if we observe right half of the portion, we are sorting the array from right to left. If we observe the left of our portion, we are sorting the array from left to right. So rather than sorting the array from left to right, when we place all our pointers from first position, we are sorting the array from left to right in left half of the array, and right to left from right half of the array. This will essentially decrease the traverse path or iterations which we have to do. So due to this, so we'll start iteration from the first element. Let us say we'll start iterating using a variable called x. So we'll be iterating till it reaches an index called p of k. Yeah. So what is the responsibility of this x variable? So as we have discussed, the motto, whenever it finds a value I, it essentially has to send this value I to left of the pointer, suppose called pos of I. Yeah. So this is our motto. So now we shall go into detail of how we will send this I to left to pos of I index. Now, when x finds a value I, and if I is greater than k, I is less than k, now we'll just swap the element at x. The element at x is now I, with the element at index pos of I, and next we'll increment the pos of I. So this will essentially make sure that the I is left to pos of I index. Yeah. So additionally, this I is not only left to POS of I index, but is I is should be less to POS of I plus 1, POS of I plus 2, all the way to POS of n minus 1. So since we are starting this POS of k to POS of n minus 1 from the last element, and now since we have swapped this I to the left hand portion, because I is less than k, we don't need to do any changes. These pointers will essentially be right side to this I variable. But we have to make sure that all the values pos of I plus 1 to pos of k minus 1, which are starting from first element, are right side right to this value I. So to make sure that we have to increment POS of I plus 1 to POS of k minus 1, not just incrementing POS of I is should be fine, but we have to increment this index as POS of I to POS of k minus 1. So this will make sure that I will be left to all these indexes. Yeah. So this is what when I is less than k. So now, what if when I is greater than k? Here as well our code is same. So we have to send this I to the left of the pointer or left of the index pairs of I. So to do that, we'll be swapping element at index x, which is I, with the element at index pairs of I minus 1, and then we'll be decrementing this pairs of I minus 1. Yeah. So here, rather than in when for I greater than k case, rather than swapping with pos of I and incrementing it, we are swapping with I minus 1 and incrementing this. So why we are doing this? Why we are doing a different thing for I called I greater than k? The reason is because since we are starting this when I is greater than k, all the pointers are starting from last element, right? Suppose let us take an example in the when we start an iteration using this x, if the first element I is greater than k, now we have to make sure that this I is left to pairs of I. So this pairs of I start from last element since I is greater than k. So in this case, we can't since pairs of I is already at the last element. We can't send this I. We can't make sure that I is left to pairs of I, right? So due to this, what we are gonna do is we're gonna be decrementing. We're gonna be not decrementing, we're going to be swapping with position of I minus 1, and then we're going to be decrementing it. So this will make sure that I is right to pairs of I minus 1. So if we do the same for all the pointers in the which are starting from last element, at the end we'll end up in a position that all a value I is left to the pairs of I. Yeah. So we for all the elements which are starting from last element, we will be following the same. We'll be swapping with pairs of I minus 1 and decrement this. At the end, we'll essentially will be in a position where I will be left to pairs of I. So if we follow this same approach for all the pointers which are starting from left side. Yeah. So this is what will be doing when I is greater than k. When is I is less than k, we will be just swapping with pairs of I, and we'll be incrementing pairs of I. And also apart from pairs of I, we'll be incrementing pairs of I to pairs of k minus 1. And then when I greater than k, we'll be swapping with pairs of I minus 1 and decrementing pairs of I minus 1. And along with pairs of I minus 1, we'll also decrement pairs of k all the way to pairs of I minus 1, because we have to make sure that this I is not only right to pairs of I minus 1, it also be right to pairs of I minus 2, pairs of I minus 1, all the way to pairs of k. So due to this, we will also be decrementing this as well. Yeah, so when I is equals to k, so now what will it do? So when I equal to k, we won't do any swapping, we'll just increment x to the next position of the array. So why we are doing this? So as when I is less than k, we are just sending these values to left of pairs of k minus 1. When I is greater than k, we are sending the values to the right of pairs of k. So this will essentially make sure that when I is equals to k, the values will essentially between pairs of k minus 1 and pairs of k. So since it is already been taken care, we don't need to do any swapping. We just need to increment x to the next element. Yeah, so this is the idea of our algorithm. So basically, we are using n pointers, where n pointers, or best way I can call it as markers. We'll be using n markers, where each marker represents a group of same value of numbers, and each pointer has a value in the represents the index of an array, where suppose if we say pi, the pi contains the value which represents the index in array, where all the elements which are having value I will be less than the index pi. So that is what a marker represents, or what a marker has. So we have essentially used this concept of markers to sort an array. So now first we are traversing the elements of the array, and then when we find a value I, we are sending this value I to the left of its relevant marker pi. When we find 0, we will send it to left of its relevant marker p0. When we find p1, left to marker p1, and when we find pn minus 1, left to mark pn minus 1. So this will essentially make sure that our array is been sorted. And then we have decreased our traversing path all the way from first element to last element by making sure that uh, starting positions of some of our pointers are from last element. Yeah, so this is the idea of our algorithm. So this is the computer program of this algorithm. So this is the method which we can see: sort zeros to n's. This will essentially take two parameters, an array and an integer n. So an integer n represents the largest value this array can contain. It means that when we are given n, it means that we'll have all the way from zeros, ones to all the way to n's. And inside this, first we have to create pointers. So we have to have n pointers. For n pointers, I will be creating an array, so which is of size n, and I will be starting half of the pointers from starting from first element of the array, and other remaining half of the pointers from the last element of the array. So here the k is n by 2. I will be starting pos of k all the way to k minus 1 from the first element, all the way from pos of k minus 1 pos of n minus 1 from the last element. Yeah, so now since we have created the pointers, now we have to start iterating through the our given array. So we'll be iterating using this variable called I x. So this x will be starting from 0 and all the way to pos of k position. So this pos of k will be starting from last element of the array. So now, um, when as we have discussed, when x finds a value called I, if I is less than k, we'll be essentially swapping the element at x with the element at position, or at element at index pos of I. And after we do that, we'll be incrementing pos of I all the way to pos of k minus 1, and also we'll be incrementing x as well. When in the case of when I is greater than k, we'll be swapping the element at x with the element at position or index pos of I minus 1, and then we'll be decrementing all the way from pos of k to pos of I minus 1. So this will essentially make sure that the value I is right to pos of I minus 1. So since we are following the same approach for all the left arm pointers, at the end we'll be end up in a position where I, all the elements which are having value I, are left to the index pairs of I. So now when I is equals to k, we won't do anything. We'll just increment to the next element. Yeah, so this is the computer program for this approach. So basically we have used this pointers or markers to divide our array. We are using n pointers to divide our array into n plus 1 positions, and in this n plus 1 parts, we have placed our n plus 1 distinct numbers, zeros, ones, 2, all the way to n's. We have placed our n plus 1 distinct groups in each n plus 1 parts of the array. Yeah, so that is what we have done in this approach. So basically, we have seen three approaches to solve this problem. One is using sorting algorithm, next is using tracking and storing the count of zeros and ones and twos, and other is using the pointers approach. Or else, I can say using the concept of markers, where each marker represents a group of same number of values, and each marker value represents an index in array. Suppose if pi is a marker, the pi represents the index in the array such that all the elements which are with values I are left to the index pi. Yeah, so we have used this concept of markers in solving this problem. Yeah, so this is what for this in this video. So see you in the next.